Okay, so let's get rolling. Um, First of all, I'll go ahead and I'll poll the class. Would you want to? We're going to be doing JSON stuff to read in our map. Do you want to transition to Unity first and do JSON within there, or do you want to finish doing JSON in Java? How excited are we about going into the game engine versus finishing the stuff up here? Any go ahead. Well, we're doing that anyways. That's going to happen regardless. We have to go from Java to C Sharp, and instead of it living on online GDB, it's going to live inside of Unity. We're going to have to work with a tool called GitHub, which the CS Club put on a thing about that nobody showed up to, by the way. Literally zero people showed up. So please take advantage of those things when the CS Club spends time putting those things up. But we'll be using GitHub, which is another industry tool for storing our stuff. So we wouldn't be using online GDB anymore. We'll be using probably Visual Studio Code or Visual Studio, which plugs into Unity. Probably Visual Studio instead of Visual Studio Code, but it plugs into Unity, and then also GitHub for storing our stuff. But that's happening regardless of whether we transition to Unity now or transition to Unity in a week and a half or something like that, 2 weeks, around week 8, like I had advertised. So I'll leave it up to the group. Do you want to get to the game engine sooner rather than later and start diving down that route, or do you want to kind of finish up with Java in our current thing? Go ahead.
So we need like a membership or something.
It's not going to cost you anything. It's free for students. You just have to download something. It's a pretty big download. It'll run on your computer. If you have an older computer, it might be a little bit sluggish, but it'll run on everybody's machine unless you're working off a calculator or something. Uh, so anybody have strong opinions online, people? Strong opinions? You want to do what? Like now? Or like you want to start doing Unity sooner rather than later? All right.
I mean, what do you think is the most optimal?
I don't really care. It's fun for me regardless. I probably prefer not having the front end stuff, so I probably prefer sticking with Java or whatever, just so it's code, not. I think early on in 200, I probably said it where when we start writing these games and stuff like that, what we're really doing is thinking about it like giving a dog its medicine by hiding it in its food. So we're learning computer science stuff by making little video gamey things, but ultimately you're learning computer science stuff. Um, so, uh, so that because that will drive what the assignment will be over this weekend. If we want to transition to Unity, what I'll probably do is give you an initial Unity tutorial to do over this weekend. There's a tutorial I like using called Rollerball, which takes probably about an hour and a half or 2 hours to basically follow a video and things like that. It's just monkey see, monkey do. But it introduces you to the basics of Unity, so that when we come in on Monday, we would have that as a starting point. So we want to go that route. Another over the weekend hard program. You want to follow a tutorial, or the nightmare is going to show up at some point regardless. It'll be over the weekend following a tutorial. I'll finish up our assignment in class today. You'll go through that tutorial, which is mostly just going to be a time commitment. Download Unity, spend an hour and a half following a video, pausing it, doing what it said to do to get this ball rolling around on the screen using the arrow keys, collecting things and stuff like that. So, all right. So we'll go that route. I'll put it up after class, the tutorial thing, so everybody can kind of get going with that. So let's finish up the assignment then, so we can transition. We're still going to do the transition to JSON because we're going to keep doing our dungeon thingy over on Unity. We'll have to kind of reimagine aspects of it, but but we're still going to be reading in our map from a JSON file rather than hard coding the stuff and all that jazz. Okay. So let's see. Our assignment for today, as my computer is giving me this thing, was to get monsters running around the dungeon, something like that. All right. So last time in Room, we taught rooms how to hold on to a monster. We also, let's see, inside of our dungeon, we created a monster, and we created this troll. We originally put that monster in the first room. We built something called a monster controller. Well, first of all, just for monster, we expanded monster. Well, we didn't actually expand monster yet. We said monster is a player. So they just start off as everything that a player is. And if we remember that from a player's perspective, players know about the room that they're currently in. So then inside of room, we wrote a function called set the monster, which works basically identically to set the player. So it takes in a monster we're adding to the room. This room becomes aware of that monster. So he remembers the monster that's in the room. And then he also lets the monster know about himself. So this is when the monster becomes aware of the room that it's currently in. Room knows about the monster, monster knows about the room. So we have ways of getting at our monster and the rooms that we're in that way. Then we built our monster controller. And this is our thread. So we can kind of think of this as like this robot sitting over here that's almost like holding on to our monster like it's a chess piece, right? And moving it through our dungeon and things like that. So when we build a monster controller, we build it with a monster in mind. So this guy remembers the field that is the monster. Our run function, remember this is the thing that when threads call their start function, the run function inside of the thing that follows the runnable interface, which threads do, gets called. If we don't do anything here, if we don't write this run function, we get the generic default one from thread that does nothing. So it's a very boring thread that does nothing. But so we'll write it in here. So we just decided that, hey, forever, we're going to go ahead and we're going to try to go to sleep for a second. Then we're going to decide whether we want to move or not. We'll go ahead and roll the dice. If we rolled a 1, we're going to decide whether or not, well, if we roll a 1, that means we're going to move. Now we got to decide in which direction, which exit are we taking? All right. So that's kind of where we left it off here. If we don't roll a 1, which means we rolled a 0, when we're just dealing with a two-sided die, actually we would roll a 2, right? Because we're dealing with a two-sided die would be either a 1 or a 2. So if we roll a 2, we're just not going to do anything. We'll go ahead and spin back up. The loop will come back down. We'll sleep for another second and try again. All right. Now, good programming practice, I would probably say we can move our creation of our dice object to the beginning of run rather than recreating it every single time through our loop. Realistically, the compiler probably did that for us behind the scenes. Compiler is one of their jobs is to make us look like better programmers than we are, because it takes that high level programming language, in this case Java, and turns it into low level language, assembly code, or actually in this case it's assembly for the Java virtual machine. So it probably made us look better than we were, but we technically only need to get the two-sided die out once, right? And then we can just keep using it over and over again. All right, so what do we do if we roll a 1? Well, we want to go ahead and create a dice object that has enough sides to cover the number of exits that are in the current room, right? So right off the bat, how many exits are in the current room? Well, what is the current room? The current room is the room that this monster controller's monster is currently in. So let's go into player, since right now monsters are players. And players, as well as monsters, have the ability to give us the current room. So let's get that first, just so we have that variable to work with. So we'll go ahead and we're going to say room, current room is equal to this dot the monster dot get. Yep, thank you. I was just copying it so I didn't spell it crappy. Play defense. All right, get current room. So now this object right here holds the room, the pointer to the room that the monster is currently in. All right. Now we need to know how many exits are in that room. So let's go into the room object. We go up to the top. We see that our exits array has a maximum of 4 exits, but the actual number of exits in a room is cur number of exits. So one thing we can do, and this I mentioned out loud last class, we can decide, do we externally take in, do we, inside of monster controller, do we get the number of exits in a room, then roll the dice to find out which of those exits to take, then tell the room I want to take exit 2? Or do we build into room a function called like take random exit, that in here we just have to say, okay, current room dot take random exit, and we well, since we know we're a monster, it would be the monster that's in that room, so we don't even have to pass it anything, and it just figures out which exit we're going to go through. That's probably the cleaner way of doing it. So what I'll do is I'll go ahead and take this guy out. It's the same code. It's just, where does it live? Does it live in monster controller, or does it live in a room? All right. Oh, I already started writing it. So take random exit for monster. So this guy's only going to do anything if we have a monster in this room, which, based on our monster controller, we know there's a monster in this room, because the only way we got access to this room is by asking the monster what room is it in. Okay, but in any case, so now we need to go ahead and we need to generate a random number between 0 and the number of current number of exits, so that we can grab one of the exits from our room. All right, so we'll go ahead and create a dice object. And the number of sides for this guy is going to be cur number of exits. All right, and then we can go ahead and just say int roll is equal to d dot roll. So this is going to give us a number between 1 and current number of exits. Go ahead. Well, I mean, I can't tell you. I have to see the code. It's not going to throw us an error here. So I'd have to see it if you want to bring it up after class or something. So we're going to go ahead and roll our dice, d.roll, which is going to give us some number between 1 and this number inclusive. Now, remember, we're using this value to access an index of an array. So up here, we want to use that number to access one of the buckets inside of available exits. And arrays are 0 indexed, right? So we need to actually subtract 1 from our roll so that we have a number between 0 and cur number of exits minus 1, which are the legal buckets in our array where an exit lives. Okay. So we'll go ahead and say exit, the exit to take, is equal to this dot available exits at bucket, roll -1. Make sense? So now we're holding on to an exit. This is the exit the monster is going to take. The guy's sitting right here. All right. So what does it mean to take an exit? Well, an exit has a destination, which is another room. That's the room we're going to be going into for the monster, as well as the direction it's going to lead. So if we wanted to spit something out to the screen saying the troll moves to the north or something like that, we could. But the place we're going to go, the ultimate place that we're going to add our monster to, is the destination room. And we can get that by getting the destination room from our exit. So what we would do is we would say room, doing this inside of room, right? Room destination is equal to the exit to take dot get destination room. All right, so now we have the room that we want to put that monster into. So right off the bat, we want to go ahead and, well, order of operation here does matter, because I could say, well, what I want to do is I want to remove the monster from the current room and I want to put them into the next room. Well, if I want to remove them from the current room, I would probably set the monster in the current room equal to null. But if I do that before I add them to the next room, now I've lost access to my monster. I could temporarily store the monster, or I could add him to the new room, then remove him from this room. So we'll go ahead and say destination dot ninja. Oh, we're already in there. Set the monster to this dot the monster. This adds the monster to the destination room. Then we want to say this dot the monster is equal to null. Now we don't need to worry about updating the monster on what room they're currently in, because set the monster for room, let him know, let our monster know about the room that they were just added to. So the only evidence, the only trace of that monster currently is in this other room that they just left. So that's where we remove the monster from this room. Now, if we want to have a little commentary, we can just do like a system.out, maybe the name of the monster, leaves to the whatever the room's direction is. So we could do something like system.out.println. Probably just called get name from player. Yeah, get name. So we'll say I'm actually going to move this before I delete the monster, because we've lost access to our monster already. So I'll print out this dot the monster dot get name, concatenate onto that, say leaves to the, and then we want to concatenate onto that the direction related to our exit. Do exits give us our direction? Yep, get direction. So our exit is called the exit to take dot get direction. So we're going to print out, in our case here, a troll leaves to the whatever direction they just left to. Then delete that troll from the current room. We still needed access to him right here. That's why we didn't want to set him to null before we did that line. Go ahead. Dice object we wrote in monster controller. He's going away. You're gonna, well, I got rid of it. We had a line in here that would have been throwing an error because we didn't pass in the number of sides. Well, because now we're doing it inside a room. Inside of room, we decided let's just have a function called take random exit for monster, which we would put inside of the monster controller. So we would say current room dot take random exit for monster. That's what our monster controller is going to look like. We'll go ahead and get the room that the monster is currently in, and then we'll tell that room that I want my monster to go into a random direction. And then all the logic for that now lives inside of room. Where as long as there is a monster, we build a dice object with enough sides, we roll it, we grab the exit associated with what we rolled, -1, since arrays are indexed 0 to something where our dice roller gives us 1 to number of sides. Then we'll extract the destination room from that exit. Then we'll set the monster into that destination room, which then also lets the monster know that they're in the new room. Then we're going to print out some commentary for the user to see that the monster just left in some direction. And then we'll go ahead and officially delete the monster from the current room they're in because they've already been put into another room and we no longer need access to that pointer to get like names and stuff like that. All right. And we're only going to do this if there is a monster in the room, but we know there will be a monster in the room because we're getting our room from a monster. The monster is telling us the room they're currently in. And we're only going to do this inside of our monster controller if when we rolled a D2, we got a 1. If we got a 2, we'll spin up, wait another second. Go ahead.
Why does it have to be a dice?
Well, it doesn't have to be. We can create an instance of random. I think I'd asked last time, do we want to do this with a dice object? Well, if you set it to 1, that means they'll always leave. Where we're creating a situation where every second the monster might go somewhere else. But I think I mentioned last class that the random class has a function in it called next Boolean that gives us a true or false. So if we only need to flip a coin and we didn't already have our dice object to just boom create a two-sided die, we could use the random object to just give us a true or false and move on with life. So, all right. So as of right now, let's make sure we're spinning up a monster controller. Inside my dungeon, we created a monster. We set the monster into room 1, so the monster goes into the same place the player starts off at. We build our monster controller passing at that monster, and then we tell that monster controller to start. Now, one thing I'm going to do here is I'm going to move the start for that guy down after we add all the exits. Otherwise, you could have, remember when we talked about race conditions with threads? Your monster might try to take an exit that hasn't actually been there yet, been put there yet. Actually, he wouldn't try to do that because the exit hadn't been added. So I think we would have been safe, but it would have been a little bit weird if he starts talking to rooms that don't have exits in them. So we might as well have our monster start the monster controller thread. Put that at the end so we know our dungeon's been completely built by the time we tell our troll to start potentially wandering around. All right. So troll leaves to the north and he goes back to the south. So he's back in the room now. Back to the north, back to the south. Oh, come on. You can do it. Okay, he went north, north, south, north, east. Okay, so he's in room, whatever that was, at the cross to the right. So if we start going up there, we see there's no monster there. I think there might, oh, now he's back to the south. So, well, there's a troll we caught him. So now we're chasing the troll around the dungeon. All right, so does that pretty much solve the homework assignment? All right. So let me save that, share that, copy it. And if you're on Slack, the channel I've been putting this stuff in is the same channel that you were in from last semester. So it's currently CSC. I renamed it 2050, fall of 2024. Really, it should be spring of 2025. But troll moving around dungeon code. Good.
Monster for the exit to fake. Like, why do we do the roll -1?
Because our dice, let's say the current number of exits is 3. So I'm in a room that has 3 exits in it. Well, my array, the legal buckets are 0, 1, 2. But my dice object is going to give us a number between 1, 2, and 3. So I have to subtract 1 from that to make sure I'm accessing a legitimate part of my array. Or we could have not used the dice object and gotten a random number between 0 and the actual thing non-inclusive. But that's why the -1 is there, is to map our dice to legal buckets in our array. Otherwise, we would sometimes get an array index out of bounds error. Actually, we wouldn't get that in this case. We would get a null pointer exception. If we tried to access an exit that lived at bucket 3 in that array when the only things that are filled up are 0, 1, and 2. Go ahead. What do you mean another method? Oh, we certainly could. So what he's asking is, instead of kind of manually doing this, which is let's see, was that an exit? Where do we write that? No, we wrote it in room. So in room, we have a function somewhere in here. Take exit. So what he suggested is, well, couldn't we have asked the room to go ahead and take the exit, basically rewriting this function for a monster? We could have. I mean, it's I guess a dealer's choice type thing. The same logic is there. The difference here is our take exit is more complicated here. If you remember when we had players type in a string, we passed that string. It first checked, is there an exit in that direction? With our current code, we know that this exit exists, right? We've extracted the exit from the room that we're currently in. Then we go through, we find the exit in that direction. We go ahead and set the player. So there's a lot of extra stuff going on here that we already know in our code down here. We have the exact exit that we asked the room for. So short answer is yes, we could have put it in a different place. This probably is the better place to put it rather than creating another function for something that's never controlled by us, just kind of something floating around. Other questions? Okay. So as you might imagine, if we kept going with this, we could create multiple monsters, multiple monster controllers, and then each one of those guys can start wandering around rooms. So if we wanted to do that, we can go back to, where's my dungeon? So I can create another monster. We just steal these 3 lines. And maybe we're going to create call this guy another monster. Have him be a rat or an ogre. That goes with trolls. Maybe we put him inside of room R5 initially, just so he's in a different place. We definitely need him in a different place since our rooms only know how to hold one person. Although we currently run the risk if both of our monsters try to go into the same room, somebody's going to delete the other monster from the room, which then will become a problem when it starts trying to ask your room for its current monster. We might get a null pointer exception, but we can at least watch it until it crashes. Call this guy MC2. So a second monster controller for our another monster. So we have two additional threads now who are dragging their own monsters around the dungeon. If we wanted this to not have a crash problem, we would just update our monster from being a single variable inside of a room to having a collection, maybe an array list of monsters, something like that. So we can have more than one monster in a room at once. And then we'll say MC2.start. So now if we run this, we're going to have two different monsters trying to where did I write it? Oh, I recopied that line. Oh. Oh, yeah, there was a, now we're getting the errors because it's trying to grab, but it's getting null pointer exceptions. Troll leaves, troll leaves. Oh, so we already broke our ogre. Ogre and troll must have ended up in the same room, and troll overwrote the ogre, so the ogre no longer has a room. And we keep catching the null pointer exception. Something went wrong in our monster thread. We keep catching that because we're trying to, if we go into our monster controller, so actually you're seeing exception handling, and we're getting into here. If we were to print out E in this case, we would get a null pointer exception because what's probably happening here is this line right here for our ogre in that last case, current room was null. And we're trying to call take random exit for monster on nothing. If we just run this again, there's at least a fighting chance that they both survive for a period of time. We are putting them in a different room, aren't we? Yeah.
You set, go back to that chat.
Did I overwrite it?
During those cases.
Oh, thank you. We never put him in the dungeon. But the thing I said before is still an accurate statement if they happen to overwrite each other in a room. So you could get a null pointer exception. Another monster. Put another monster into room 5 and then build our thread around another monster. So I think it should be better now. At the very least, we should see our ogre move a couple of times. Troll leaves to the north, troll leaves to the south, ogre leaves to the west. All right, so we got these monsters roaming the dungeon here, and we're kind of rolling the dice if one overrides the other one. All right. Say this again.
It's not an error or an exception.
It would be if they end up in the same room. I mean, at this point, they haven't overwritten each other. So they've always abandoned the room before the other one came in, because otherwise it would be whoever ends up in the room last would override the monster that's currently in the room. And then when we ask that monster for his current room, it wouldn't have a value, and we'd get the null pointer exception. All right. Now, pause it there. Let's talk about some more design pattern stuff leading us into Unity. Now, we had previously talked about the idea of design patterns, where the concept is it's a proposed good solution to a common problem. And the design pattern that we've already looked at is something called a singleton. Okay, a singleton, we said it's a good idea when something needs to be shared among multiple objects that we put it in a single location that they all have access to, rather than passing that information across all those different objects, kind of having to create a whole bunch of interconnected wires. Somewhere in there, there's a balancing act where maybe if you only need to make information available to one additional object, you just go ahead and give it the one piece of information. But if you need more than two total objects who need access to it, maybe you put that in a singleton so they can conveniently access it. One issue with singletons is it's easy to, out of convenience, throw everything into that one global object that's filled up with static stuff, because now all your stuff can easily access it. So you end up getting 4,000 variables that are up there that maybe don't really need to be in a singleton. So it's a little bit of a trade-off. But I want to introduce another design pattern here called MVC. This is Model View Controller. So as you've seen, as we've gone through last semester into this semester, we've seen that our code is getting more and more complex, right? We keep adding more objects. You know, what do we have now in this one? 10 files or something like that. Okay, so the idea is if you go back in time, so really this design pattern came from kind of the early days of web development. You know, as our web pages kept getting more and more and more complex. If you looked at the code that was behind dynamic web pages, you would get into this humongous file filled with all sorts of stuff. The user interface was in there, the logic was in there, everything was all inside this one file. So it became difficult to manage. So what MVC says, it says it's a good idea to keep your user interface separate from your logic, separate from your data. So if you have a program that has a database behind the scenes somewhere, and you have a program that has a whole bunch of logic, which every program is going to have some logic in it, and then you also have some user interface, whether it's a pretty user interface or a junky user interface like we have here, keeping those in 3 separate locations so that if you need to change the functionality of some aspect of it, you go to the controller part of your code. Question? I hope that's what you got. So, so maybe make your notes so it's clearer to you, I guess. You know, we have 3 different things. Models. So a model is stuff we want to store, usually in a database, which we really haven't talked about, but we imagine that if you have programs and you want data to persist across every time you run your program, you're going to have stuff that you're going to store somewhere. Those are called models in this thing here. A view, this is the user interface. The controller, this is our code logic. All right. So hence the reason I named our monster thread the monster controller. He's in charge of the logic of moving our monster around and that kind of stuff. Okay, so these are the 3 different things. Now remember that design patterns are just an idea, not an implementation. Okay, so we have this idea, this MVC says it's a good idea to keep these 3 things in separate places. So every time you work with a new technology, you're at the mercy of how do they implement their version of MVC. Okay, and the reason I'm introducing this now is you're going to see very quickly in this tutorial them introducing the concept of MVC for Unity. Now, we're not going to be getting into the model part of it for a while, but clearly we're going to have what our game looks like, the user interface, and we're going to have code that makes things happen on our user interface. And Unity separates these two. We're going to have this design window that allows us to drag 3D objects on there and give them names and stuff like that. And then we're going to have code that lives behind all that. And we have to have a way of connecting those two together. All right. So we want to have the ability to have those two talk to each other in some ways. If we need to expose a variable from our logic to the user interface, we can do that in Unity. We just make the field public in Unity. It's fairly easy. There's nothing special you have to do, but that's how they do it. Similarly, if you're in code and you need to, or you're in your user interface, you need to make something available to your code, you can link those up as well. So it's a two-way street. All right. So we can kind of put in here each. Let's see. MVC implementation. Each technology has its own way of accomplishing this. For example, what we used to do in this course before we started using Unity is we do it with Android development. Whether it's Android development or iOS development, it's the same mentality. The difference is if we do iOS, everybody has to have a Mac. Android doesn't matter. It works on all the computers. But Android had their own version of MVC. How do we keep things separate and how do we connect them to each other? And while it had a lot of commonalities to maybe how iOS did it, it wasn't the same. You had to kind of learn that the system, the way of doing that. Similarly, Unity does it differently as well, but these are all the way that they handle that design pattern. So again, the design pattern is not an implementation. It's an idea that then often gets implemented. So what we're kind of pointing out here is the idea of common design patterns. When I first introduced a design pattern, I probably said something along the lines of, this was born out of, in higher education, we have this concept called publish or perish that you've maybe heard of before, where faculty are supposed to be doing original research and writing papers and all this stuff. And design patterns tend to be an easy way, kind of a cop-out for that, where there's all sorts of examples of what are common problems, right? Probably when I originally introduced it, I probably talked about like making a peanut butter and jelly. Everybody has like maybe their approach to the peanut butter and jelly process. Like, do you spread the peanut butter with a knife, possibly ripping the bread, all this stuff? What's your approach to making a peanut butter and jelly? And maybe there's 2, 3, 4, 5 different acceptable ways. But in order to have a design pattern, you just have to come up with a funky name and an approach. And for doing research, it's okay to say this doesn't work. So to do original research, you just have to come up with a funky name, come up with the problem you're attempting to solve that you're proposing this good solution for, and then at the end say, no, this doesn't work. Okay, in fact, never do this. This is a horrible idea. And then you go get it published, move on with life. So that's kind of where these things came from. But if we just throw a slide here for popular design patterns, we've already seen singleton. We've seen MVC. There's another design pattern known as the factory design pattern. And this actually is similar to singleton in that a singleton it's a good idea to store stuff in a central place, Where the factory design pattern is, you know, if you have something that needs to logically happen, and it's something that commonly happens across your program, rather than writing that logic into one of your objects, you bring it to a global position, basically in a singleton, a factory that has those functions in it. So no matter which of your objects needs to have that ability, they can just call upon the factory to do this. It's kind of like how e-commerce shops work, where you know people design t-shirts and things like that. Yet there's a place out there that if you upload a design, they print the t-shirt, they ship it out, they do all the other stuff, and they just send you your $2 for you know your cut of it. So that would be a factory that does all those things for you, and all you do is interact with that factory for doing all the work. All right, so that's another common one. You know, there's other ones you'll bump into, but I would say these are probably the things that you're going to see. In fact, I can't even think of another really common one you might bump into. And even here, we see that singleton and factory are basically the same thing. One's storing stuff, the other one's doing stuff. All right. So, comments about that, questions about that. So let me show you where we're going here. So if you do Unity Rollerball, it's going to take you to Unity Learn. And here is that first. I mean, there's lots of other things that are good ways of learning Unity. What I like about this is it kind of hits all of the things that we're going to be using in here, or most of the things we're going to be using in here in a very compact way. So you can kind of quickly get up to speed so you know enough to be dangerous. All right. You know, so as you go through the tutorial, you see first thing is setting up the game. So it's going to have you download Unity. If you go to Unity, I think it's unity.com. Unity.com here, you don't have to worry about plans and pricing. Make sure you create your account on Unity with your .edu address. If you don't, it's not the end of the world, that you'll just have to like upload your student ID or something like that. But I think that when you create the student account, if you have a .edu, it just makes it work. But when you look at products here, we have something called Unity Engine. So this is the actual game engine that we use. Effectively, what's a game engine? A game engine, I see we're out of time. A game engine is a tool that brings all the physics together so that we don't have to do all the math. Our game just has gravity and it looks right, but we didn't write it. All right. So what I'll do is I'll put up this assignment dealing with this tutorial. So over the weekend, you'll be downloading Unity. I would get that downloading as soon as possible from this website. That way you have time to get it updated and all that stuff. It's a pretty big download. Otherwise, I think the assignment's probably going to take between 1 and 2 hours. If you have familiarity with Unity already, it's going to be a lot quicker than that, actually. So I'll put the assignment up here in the next hour or so, and I will see everybody on Monday. Remember, I think Monday the hackathon, the 10th? Yeah, so if you have not already signed up for it, I strongly encourage you to get involved in the hackathons. Another good learning opportunity where you get to banter with some other students. Even if you think you're not going to be able to give that much productivity, you'll still learn from the process. All right. And one sec. Gavin, are you just online?
Yeah, I'm online today.
Okay. Here, let me stop the recording and then can chat about whatever.
Thank you.
Yep. Have a good one.